Welcome to the world of Apache Kafka. Kafka is a powerful tool used by many companies to handle large amounts of data in real time. In this video, we're going to explore the fundamentals of Kafka, what it is, how it works, and why it's so important. Kafka is a real-time data streaming platform for modern applications. So, what exactly is Apache Kafka? At its core, Kafka is a distributed event streaming platform. This means it's designed to handle real-time data feeds with high throughput and fault tolerance. Think of it as a central nervous system for your applications, allowing them to communicate and share data seamlessly. Kafka serves as both a message broker, where it publishes and subscribes to streams of records, and a storage system, which stores these streams durably and reliably. Let's take a closer look at how Kafka enables real-time data streaming. Imagine you have various data sources like applications, logs, and events constantly generating information. This data flows into a Kafka cluster, which acts as a stream processing hub. From there, consumers such as analytics tools and dashboards can subscribe to this data and process it in real time. The benefit of this architecture is that events are processed as they occur, enabling millisecond latency and real-time decision-making. Now let's dive into some core concepts of Kafka: topics and partitions. Think of topics as categories or feeds where records are stored and organized. For example, you might have a topic called User Events to track user activity, or Payment Logs for financial transactions. Within each topic, data is divided into partitions. Partitions are ordered, immutable sequences of records. This division allows for parallel processing and scalability, making Kafka incredibly efficient. Kafka has two essential components: producers and consumers. Producers are applications that send data to Kafka topics. Kafka handles load balancing automatically, ensuring efficient distribution of messages. Consumers, on the other hand, are applications that read data from topics. Consumers often organize themselves into consumer groups for parallel processing, allowing multiple consumers to work together to process data from a topic. Kafka operates using brokers and clusters. A broker is an individual Kafka server that stores and serves data partitions. A cluster consists of multiple brokers working together. This setup provides fault tolerance and load distribution, ensuring that your data is safe and accessible even if one or more brokers fail. Multiple brokers work together for high availability. Kafka offers several key benefits that make it a popular choice for data streaming. First, it provides high scalability, capable of handling millions of messages per second across distributed systems. Second, Kafka ensures data durability. Messages are persisted to disk and replicated for safety. Third, Kafka delivers low latency, often achieving sub-millisecond message delivery for real-time applications. Finally, Kafka offers fault tolerance with automatic failover and recovery, ensuring no data loss. Kafka's versatility makes it suitable for a wide range of use cases. It can be used for real-time analytics, allowing you to process streaming data for instant insights such as e-commerce recommendations and fraud detection. Kafka is ideal for event-driven systems, enabling microservices communication for order processing and notification systems. It can also be used for log aggregation, allowing you to collect and process application logs for system monitoring and error tracking. Kafka also supports data integration, connecting different data sources and sinks for ETL pipelines and database synchronization. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.